Okay, this is going to be me going through the 2024 Unit 4 Stats and Mechanics. As always, just to remind you, we've got to show enough working out to demonstrate the maths that we've done. So whenever we do a calculation, if we're going to type something into the calculator, 99 times out of 100, we're going to write it down as part of our working. So let's get started with question 1. So we've got a table with a bunch of information in there. The important numbers, before I start going about this question, it's important to note that there are 188 people. I've got them split up by boys and girls, and then I've got them also split up by whether they're in school, college, employment, or something else. Okay. So a reporter selects 2 people at random. Given that the first pupil is in school or college, find the probability both pupils are girls. So we want the probability of 2 girls given that the first one is in school or college. Okay, so that means what we have to do for the first person is we have to pick a girl who's in school or college. So first things first, we're only looking at people who are in school or college, and those people are these ones here. So those people are the ones in school or college, and we want a girl from those groups. So we've got 40 girls in school, 40 girls in college, so that's a total of 80. And then we've got 162 people in school or college. And then for the second person, that just needs to then be a girl. And there were 88 girls out of 180 people. But remember, we've already picked a girl. So there's now going to be 87 girls out of a total of 179 people. If I type that into my calculator, I get the exact fraction 1160 out of 4833. And if you insist on writing it as a decimal, 0.2400 to 4 decimal places. Okay. Now there are other ways to do this. You can do it as more of a conditional probability question. But this is the way that I think is simplest. Moving on. Actually, I may as well do the second way, just because some other people will want to do it that way. So again, we want the probability of 2 girls given that the first one is in school or education. So we want this is the same as then, write in the probability of a girl in education, girl in school or college, and then the second person being a girl, divided by the probability the first one is in school or college. Okay, so the probability of getting a girl in school or college, well, it's those 80 people we talked about out of the original 180 people. Then my second person has just got to be a girl, and we've used one of the 88 girls, so there's now only 87 different ones left to choose from out of a total of 179, because one person has gone from the whole group. And then we need to divide that by the probability that somebody is in school or college, and that's that 162 from the original question out of 180. And so you can see a lot of cancelling is going to go on here. This one here is going to cancel with this one here. And then if you think about it, we've got very similar numbers to what we had before. We've got this 80, which is this 80 divided by 162, multiplied by 87 over 179. And so you can see this is going to give the same answer, no matter which way you do it. Moving on now. Okay, having a look at this question, we've got a right angle triangle. Now, a very odd thing to come up in a stats paper, but if you've done enough of them, you will know this to be a uniform distribution. Okay, type of question. The smallest angle, theta in degrees, of a right angle triangle with hypotenuse 8 is uniformly distributed across all possible angles. So, I want you to think now, theta is uniform. What are all possible angles? Well, you should be thinking it can't go any lower than 0. Really, it can't be 0, but it can go down as low, not including 0. And if it's the smallest angle in the right angle triangle, well, we know this one here is 90. We know these two here have to add up to 90, which means the smaller one must be less than 45. Okay, if it's 46, it means the other one's 44, which means it's not the smallest one. So then we want the mean of theta, and remember the expectation or the mean is what's halfway between the two limits, so 0 plus 45 over 2, which is 22.5. And then the standard deviation of theta. Well, you're going to find the variance and then square root it. And remember, the variance is the difference between the upper limit and the lower limit squared, divided by 12. And then because we want standard deviation, we're going to square root that. So that's going to be 45 over root 12. Okay, and if you want to rationalize the denominator, you're going to get, what are you going to get? 15 root 3 over 2. And there are my answers of part A. There is going to be a part B coming up, so let's move on to that. Part B, the shortest side of the triangle is of length x. Find the probability that x is greater than 5. So I'm just going to go get the picture and put it in here. And as if by magic, there it is. So the shortest side, let's say we call this one theta, which is the smallest angle. That means the shortest side here would be this one. And so we can say that x is equal to, well, it's the side opposite the angle, so that must be 8 sine theta. Okay. If we want to consider then what the question is asking is finding the probability that x is greater than 5. Now that's the same as saying that the probability of 8 sine theta is greater than 5. And the reason we have to do that is we don't know anything about the distribution of x, but we do know the distribution of theta. Okay, so we want to do our very best to get the argument here in terms of theta. So that means sine theta is greater than 5/8. We're going to do arc sine of both sides. Now the inequality is going to stay as it is because sine's an increasing function. Well, at least on this domain between 0 and 45 is all we're interested in. So sine's an increasing function, so the inequality will remain as it is. I'm sure you will have done the questions where you do arc cos in here over this acute angle, and so you'll see the inequality flips because cos is a decreasing function. But when we do this, we get 38.68 degrees. You could just as easily do this in radians if you prefer. It doesn't make any difference. It's just because I've set up my original statement about the uniform distribution in terms of degrees, so I'm going to leave it in degrees. And now for the first time we can actually deal with this. We can say that this probability is the same as 45 minus this angle here over 45 minus 0, which is 45, and we should come out with a probability of 0.1404 to 4 decimal places. Okay, there we are. Moving on. Okay, question number 4. Looks like we're looking at some kind of correlation, relationship between forearm girth and bicep girth. Here we go. Why is it appropriate for Awenna to use a one-tailed test? Now, there's nothing in the question that says about a one-tailed test. However, the reason in my head it's appropriate is because in general and common sense would tell you people with larger forearms have probably got larger biceps as well. Yeah, it would be kind of odd for there to be a negative correlation because that would mean that on average, people with larger forearms have smaller biceps, and vice versa, which doesn't feel reasonable. So I would say that because in general, larger biceps, I can't spell, larger biceps, or I suppose I should probably say people with biceps would have larger forearms. Too. Okay, that's not to say that if I have a bigger forearm girth than somebody, I've definitely got bigger biceps, but in general, that's the pattern you would expect to see. Okay, so some kind of scatter graph here, an important number near the top that we need to read because we're probably going to use it in a bit. We're given r squared, so we may want r later. In fact, we almost certainly will want r later. So what I'll do is, if r squared is that, then r is going to be the square root of that, which is about 0.9702 to 4 decimal places. That's almost certainly going to be important later. Using the computer output above, carry out a one-tailed significance test, one-tailed sample at the 0.5% significance level, and we already know n is 11. So n equals 11, our significance level is 0.005, and it's one-tailed. Okay, so if we're doing a hypothesis test, let's state our hypotheses first. Now we're going to use rho. Okay, so let rho be equal to the correlation coefficient. Okay, and that's for the entire population. And remember, our status quo, what we always assume is that there is no correlation. And in this case, we're testing to see whether it's appropriate to say that there is a positive correlation. We know that our test statistic is that number in blue that I found before, 9702. There's a bit more to it than that, so you could say just the square root of 0.9412. Our critical value, this is what we're going to get from our table. So we're deciding one-tailed test, significance level of 0.5%, and then we're n equals 11, and we should see that the critical value is 0.7348. Okay, I suggest drawing a little diagram. We've got our critical value here at 0.73, and then we've got our test statistic significantly further to the right at 0.97 and a bit more. So we can then conclude, since 0.9702 is greater than the critical value, okay, this is a more extreme result than we're happy to conclude is just by chance. So we have sufficient evidence to reject H0. And what does that mean in this context? Well, we've got sufficient evidence to suggest that there's the positive correlation. Sufficient evidence to suggest. And you do need to say positive here. Positive correlation between, what is it, forearm girth and bicep girth. Okay, that word there, positive, is really important. You won't get this last mark without it. Okay, we haven't proved there's correlation. Oh, we haven't proved anything really. We haven't proved that there's sufficient evidence to suggest correlation, or just correlation. We've proved that there's sufficient evidence to suggest positive correlation. So state that. And moving on. Different character now. We got Blodwen. Decides to do the same test using all 507. So we've got significantly more data points to look at here. Looking at .E1, state the problem Blodwen will encounter when attempting to use statistical tables. If you have a look at your stats tables, we don't have n going up as high as 507. N does not go up to 507. How should she deal with this problem? Now, I would imagine the most common wrong answer here would be something along the lines of use a sample. That is not going to get you the marks here because it says she wants to use all 507. So there's a couple of things I might suggest. Probably the main one is use some kind of software package, use some kind of data analysis package that'll do this for you. So use a data package or software to carry out the test. Okay. The other thing to notice is that if you were to look at all the critical values, as the n increases, the critical values come down, and so that's one way to know what you're doing. But you've got to really make sure you stay away from saying take a sample, because then she wouldn't be using all 507 bits of data. And we're going to move on. Okay, after a question of lots of writing, hopefully this one now is going to be doing some calculations. So we've got Jake working for a delivery company there. So right, let's define X equals the mass of a parcel. Therefore, X, and they've told us all of the parameters here. So the mean is 2.2, standard deviation is 0.3, so variance is 0.3 squared. Calculate the probability that X is less than or equal to 1.8. Your calculator is going to do all the heavy lifting for you here. So you're going to go to normal CD. You're going to put your lower as -1 times 10 to the 99. You're going to put your upper as 1.8. Your sigma is 0.3 and your mu is 2.2. Type all that into your calculator and you should get 0.0912 to 4 decimal places. Okay. Jake delivers the lightest 80% of bikes on his parcel. He puts the rest in the car and delivers them by car. Find the mass of the heaviest parcel he would deliver by bike. So we want to find the probability of X being less than something, let's call it little x. I suppose you could call it m because we're talking about masses. And that the probability of something that heavy or lighter is 80%. You could find the probability of X being greater than little x and say that's 20%. But your calculator won't do that. So you're then going to go on to inverse normal. Same mu and sigma as before, but you want to put the area this time as 0.8, and that will output you this value. So we're going to say then that little x equals 2.452. Okay, so this is then the, it's not the smallest, it's the heaviest parcel. Heaviest is 2.452 kilograms. Okay, I suspect there's going to be some kind of conditional probability coming in a minute to do with that. So let's have a look. He randomly selects a parcel from his car, so we know it's one of those ones. Find the probability as a mass less than 3 kilograms. So we want the probability that X is less than 3, given that it's in his car. Okay, and we know that because it's in his car, we know that it's more than 2.452, and that happens 20% of the time. So we want the probability that X is between 3 and the 2.4 blah blah blah, because we know it's got to be more than that, but less than 3, because it's got to be in his car and it's got to be less than 3, and that's going to be then divided of the probability of a randomly chosen parcel being in his car, which is 0.2, because the heaviest 20% go in there. If we think about how we're going to work out the top, we're going to go to normal CD again. We're going to have the lower as 2.452, the upper is 3 mu, and I know I've changed my order around here. That's going to be 2.2, and sigma is 0.3. And when I type all of that in on the top, I'm going to get 0.1962, and then divide that by 0.2, so I'm going to multiply it by 5, so this is going to be a very high chance, 0.981. And there we go. Moving on. Okay, so we're looking at still Jake and his delivery of parcels, and he thinks that at Christmas time they're going to be heavier, and that's going to be important in a minute, I'm sure. Thinks they're heavier. He randomly selects 20 parcels, so that's another way of saying he takes a sample of 20, and there we are, there's the 5% significance level, and he finds that for the 20 of them, their total mass is 46. Okay, that's going to be handy in a minute. Because now we're not dealing with just the mass of an individual parcel. We're dealing with something to do with a sample. Okay, let X be the mean mass of a parcel. Okay, we're gonna say, well, our hypothesis is that it's not going to have changed. Okay, so we've still got 2.2, and we're investigating the claim for Jake, whether actually they've gotten heavier. Okay, under H0, we can say that X bar is normally distributed, mean 2.2, and 0.3 squared over, and remember this is when you divide by your sample size. Okay, our observed value, X bar, well that's going to be 46 divided by 20, which I believe is 2.3. Okay, and so what we're going to do is we're going to find the probability. I'm going to decide to do it the p-value method here. Find the probability of a result at least as extreme as that, or more extreme, obviously. So that is then the probability that X bar is greater than 2.3. Okay, this is our p-value. So when we work this out, we're going to compare it to that alpha of 5%. So I have all the information that I need. I'm going to use normal CD again. I'm going to put the upper as 1 times 10 to the 99, the lower limit as 2.3, and my mu is going to be 2.2, my sigma is going to be 0.3 over root 20. When I work that out, I get 0.0680. Okay, now we're going to compare that to, or I always like to put it in percent personally, there at the end, and I like to have my brackets look nice. Okay, and now we've conducted the test, we can come to our conclusion. Since 0.068 is greater than 0.05, remember when when P is low, H0 has got to go. Well, P is not low this time, so we say there is insufficient evidence to reject H0. Okay, always contextualize this. So we've got no reason to suggest that we reject H0, which means we have no evidence to suggest, it's not no evidence, it's insufficient evidence. I'll change that now. Insufficient evidence to suggest, what did Jake think? That parcels were heavier at Christmas. That parcels are heavier at Christmas. There we go. Lovely 7 marks there. Okay, moving on. And Jake continues. Okay, so he delivers parcels to area A, B, and C. Those are the probabilities. Find the probability he will have to deliver to all 3 areas. Okay, so first thing to think about here is what's the probability that he delivers to A and B and C. So the probability of A, B and C is equal to 1/2 multiplied by 1/6 multiplied by 1/3, which is 1 over 36. And I assume that's where a lot of people would finish, and that would be their answer. However, that's going to A, then to B, then to C. We could also go A to C to B. We could go B first, and then A, then C, then B, then C, then A. So there's lots of different combinations, and you should know that when you've got a group of 3 things, there are 6 different ways to order them. So the probability of all 3 is the probability of each individual one, each in particular order, A, B, C, B, C, A, all of those, and there are 6 of them in total, so 1/6 is our answer here. Okay, on a different day, Jake has 2 parcels to deliver. Find the probability that he will have to deliver to more than 1 area. So there's lots of combinations, A, B, A, C, and all those. Personally, when I read this question, I think of a 1 minus. So I want 1 minus the probability of only A twice, minus the probability of B twice, minus the probability of C twice. There's probably not much in it in terms of working out the 6 different combinations, A, B, B, A, and all of those, and adding them up, but this feels easier to me. So 1 minus, and that's going to be 1/4 minus 1/36 minus 1/9. Okay, and when I type that into my calculator, I get 11 over 18. And that's my answer to this question. Okay, maybe the next question will also contain Jake. Let's have a look. Moving on. Nope. Onto the mechanics section. So here we go. So, like before, if you've watched my previous video, which is actually the 2025 paper, so previous or next, whichever way you want to look at it, you'll know that what I do is on these diagrams, I use red and blue to split up the horizontal and vertical components of each of the forces, and I hope I'm being consistent with myself and using red for horizontal and blue for vertical. The other thing that's a little bit different in this question is you'll see that angle in the bottom left hand bit as 100. Well, that means the angle between the 16 Newton force and my red component is 90 degrees, meaning that this bit here is 10 degrees. Okay, I haven't actually read the question yet, so let's go back and do that now. Four coplanar forces. There's the word I'm after. There's equilibrium. Find the value of F and the size of the angle alpha. So now that I've seen that magical word equilibrium, what I can do is I can do Newton's second law horizontally and say left forces, sum of left forces equals sum of right forces. So I can say that 12 plus, and then the red component of F is the cos component, so F cos alpha. Okay, those are my right forces. That must be equal to 20, and it's the red component, so it's the cos component, 10. So F cos alpha. Now 10 is not a special angle that I know the trig ratios for, so I'm just going to leave that as it is. 20 cos 10 take away 12, and there's my first equation. Going to do the same thing next in the in quotation marks vertical direction. So I've now got F sine alpha, and that must be equal to, no, it's not. I've got another force acting up, haven't I? I've got the 20 sine 10, and though the sum of those two must be 16. So I then get that F sine alpha is equal to 16 minus 20 sine 10. And if you really wanted to, you could work out each of those two right-hand sides as decimals. I don't, so I'm not going to. I know that if I take each of those equations, add them together, each of those equations, square them and add them together, on the left-hand side, I'll just get F squared. That will then equal 20 cos 10 minus 12 all squared plus 16 minus 20 sine 10 all squared. So I can then say that F equals, and I'm going to type that into my calculator and get it to do all of the heavy lifting for me, and I'm going to get 14.7 newtons, obviously when I square root. Now a lot of people use that, sub it back in to find alpha. I don't like that. I prefer to do them independently from one another, and I know if I divide the sine equation by the cos equation, I get a tan equation, and then this is going to be 16 minus 20 sine 10 over, 20 cos 10 minus 12. For alpha, I'm going to do arctan, inverse tan of both sides, and I get 58.4 degrees, and those are my two answers for this question. Okay, lovely. 7 marks to start off the mechanics. Okay, a ball is projected. So yes, we got some projectiles now. So we've got a vertical tower like this. Ball is projected here with you, 4W horizontally and 7W vertically after 5 seconds. So it'll do something like this and hit the point on the ground at the foot of the tower. There's my floor. Let's use green for distances. That distance there I know is 60, and the height of the tower, I'm just going to call it H. Okay, and the time frame is 5. So what can I say? What do I know? Well, I know my initial velocity, 4W, 7W. Yeah, that is a W, not an omega. T is 5. A Well, there's no acceleration horizontally, there's minus 9.8 vertically, and I know that my displacement vector 5 seconds later is 60 and minus h. And actually, if we look at the horizontal components, this one, this one, this one, and this one, we know that S equals ut. We don't need to worry about the plus half at squared bit because a is 0. So we can say therefore that 4w, the speed in the horizontal direction, multiplied by the time that it's moving at that speed, is equal to the total distance. So I think w comes out as 3. That means then, so that is horizontally, so I should have said that. This one now is vertically. I can say that minus h, so s equals, so if w is 3, that means 21, u times t minus a times t squared over 2. Okay, type that into my calculator. 21 times 5 minus 4.9, 0.9 times 25, and you get that negative h, we knew this was going to be negative, is minus 17.5. Therefore h, which is the height of the tower, is 17.5 meters. And there's our 2 marks. Or 5 marks, actually. Okay, moving on to part B. Oh, this is an interesting question. Determine the proportion of the time that it's on its way down. Now, the way I'm thinking about doing this is, if you think back to the original picture, when it's initially projected, it's got a speed of 21 in the upwards direction. I'm going to find out when it gets to 0. So I'm going to look purely vertically again. U equals 21. I'm interested in when V is 0, so I want to find the time. And A equals minus 9.8. So V equals U plus AT. Okay, so 0 equals 21 minus 9.8 T. T is 21 over 9.8, which when you put that into a calculator, I'm sure it comes out with something lovely. Yeah, 15/7. Okay, so that means for 15/7 of a second, it's going up. That means for the rest, it's going down. Okay, so on the way down, and let's write this straight away as a proportion. Well, that's going to be this. That is the amount of time for which it's traveling down out of the total travel time. Okay, and then that comes out as 4/7. So for 4/7 of this journey, this thing is traveling down, and for 3/7 is on its way up. Okay, cool, moving on. Okay, always a good sign when there's an entire page worth of information to read before the actual question. The big grey box looks important, and this emboldened bit here is probably going to be important as well. I've got my diagram, so what I'm going to do is I'm going to label up my diagram here, and then I'm going to cut it onto the next page. So we've got a wooden beam as a rigid rod of mass 100. The steel cable is inextensible, so there's going to be some kind of tension in there. We're going to have a reaction here at the support. Rigid uniform rod of mass 100 kilos. So how long is it? 4.2, 4.4, so it's going to be about here. So that's going to be 100 G. All my forces are measured in newtons. And then let's update this with diagrams. So if it's 4.4 long in total, that means it's 2.2 to the middle. So if that's 0.7, then that bit there is 1.5. That means that bit there is 2, and then 0.2 on the end. Okay. So I think we've got everything we need now to go on to the next bit. Okay, Magic Wizards have brought my picture from the last slide over onto here. Given that the cable is capable of withstanding up to 2,000 newtons, show that the force exerted on the beam by the support satisfies the safety requirement, and then determine which one of the steel cables could meet the safety requirement. Okay, so let's take moments about where the steel cable is. So if I call that point X, so we'll do moments about point X. So that means we've got 100G multiplied by 1.5, and then that must be equal to, was it 3.5 times RS? Remember, these questions are not really necessarily to do with distances and forces, they're to do with the ratios of them. So you could do this in a ratio way if you wanted. So R sub S is going to be 150 G over 3.5. Okay, and so when we work that out, what we're going to get is 150 divided by 3.5 times 9.8. We get 420 newtons. Okay, we go back to read the question. It tells me that the steel support that I've got, I may have read that earlier as cable, sorry, but the steel support can withstand 2,000 newtons. The safety information from before said it needed to be able to withstand more than 4 times what it's currently experiencing. So if we work out 420 multiplied by 4, that's 1,680, which is less than 2,000. So it meets the requirements. Happy about that. Determine, oh I forgot this is dotty one, determine which one of the categories of steel cable we need. Well, we actually need to find the tension that the steel cable is under, and for this one I could do another moments equation, but I'm not going to. I'm going to say that tension plus the normal reaction at the support has got to be equal to 100G, so T in this case is going to be 980 minus 420, which is 560 newtons. And remember, the steel cable's got to be able to withstand 4 times that. 560 times 4 is 2,240 newtons. And then thinking back to the the grid from before, voila, the magic cut and paste elves did that. So C can't do it, B could do it, or A could do it. So we could use A or B. It would not be sufficient in this case to just say A or to just say B. We need to say both of them. So that one there, that one there. These numbers here are important, and this statement here that it meets the requirements. Okay, there we go. Moving on to part B. State how you have used the modelling assumption that the beam is a uniform rod. Well, no pun intended, the whole solution hinged on us knowing where the weight of the rod acted about, and that is what the word uniform meant. So we modelled the weight as acting at the centre of the rod. Okay, without that we didn't have any, we wouldn't have been able to do the question. Moving on. Okay, so I've got 3 forces here. The last one in particular looks pretty complicated. Find the value of the constant c and hence show the acceleration of the object is that. So the acceleration is going to be related to the resultant force. So let's find the resultant force to begin with. That's going to be the sum of F1, F2, F2 and F3. I'm going to do it in column vector. So I'm going to have 1i minus 14i plus 15c plus 1i. Then I've got 8c in the j direction minus c in the j direction plus 2c in the j direction. And then finally 11c in the k direction minus 12 in the k direction minus 5c in the k direction. And that is the same as 15c minus 12, I believe. And then in the j direction, what have we got? 10, so 9c, and in the k direction, 6c minus 12. Now, if the acceleration is parallel to the vector 1, 1, 0, that means this is also parallel to it. So let's work out an expression for A. So remember, F equals MA, so A equals F over M. So we're going to divide everything by 3. So we're going to get 5C minus 4. We're going to get 9C, and then we're going to get 2C minus 4. Always reassuring when these numbers all come out as whole numbers. Now, we could either set the I and j component equal to each other, and I've just realised that we've made a typo. That should be 3c. We could either set the I and j component equal to each other, because if it's parallel to the I plus j vector, that means they are equal, or my preferred way to do this would be to set the k component equal to 0, because this here is parallel to the vector 1, 1, 0. So I'm going to say, therefore, 2c minus 4 equals 0. C must be equal to 2. Okay, and then we can just work out what A is. Therefore, A equals 10 minus 4, which is 6, 3 times 2, which is 6, and by definition, that was equal to 0. And that's what we needed to do. Moving on to part B. When t is 0, the object has position vector r0 and is moving with that velocity. When t seconds later, the object has that position. Find r0. So we know that the position vector is equal to the initial position vector plus the displacement vector. Okay, and this is kind of a backwards one, because we normally know the initial position and find the current, the general position vector, or the position vector after a certain number of seconds, but we're asked to go the other way here. So let's think how we would find the displacement vector. Well, we know the initial velocity is, and make sure you don't get all of these vectors the wrong way around, t equals 4. We obviously want to find s, and we know the acceleration vector from before. What's clever about this question is it started off as a 3D vectors question, and by making the k component equal to 0, it meant they could then ask us a question on 2D vectors, which I really like. So we can say then, let's write this as a vector equation. We can write minus 1384 equals the vector that we want to find, and then s is ut plus half at squared, so 4 lots of minus 17.8 plus a half a t squared. Well, t squared is 16, half of that is 8, so half of 6, 6. So r0, if you do all of the rearranging, we're going to have minus 13 plus 4 lots of 17 minus 6 lots of 8, and then 84 minus 4 lots of 8 minus 8 lots of 6. And when you work all of that out, you should get, I believe, 7, 4. And that is meters. And that's our answer for this question. Okay, obviously completely okay if you wanted to do it one dimension at a time. It's less efficient, but you could work out the 7 by doing just the I components of everything and then the 4 separately. Just remember to write your answer in vector form at the end because it does specify the vector R0. Okay, moving on. If I remember rightly, this is the last question. So we've got an inclined plane and some differential equations, which is a lovely pair of topics to overlap. First thing I notice is that sine alpha is 7/25. Now 7, 25 and 24 form a Pythagorean triple, which means that cos of alpha is 24/25. Pythagorean triples, at least the first few, are really useful for you to know. What else do I know? I've got a mass of m kilograms, so mg newtons there. In addition to friction, let's have a look. It's sliding down a rough slope, so friction is there. In addition to friction, the partial experiences a variable force of mv newtons, so that's mv. Okay, and then important to note, remember that angle there is the same as alpha. So moving down the slope, I'm going to say acceleration is in that direction. And so then we can apply Newton's second law. So we're going to have the weight down the slope minus the other two forces equals ma. And then remember a is dv by dt. That's how we're going to get that differential equation out at the end. One thing actually I haven't talked about is the normal reaction there. Now because mg is the only force that's not parallel to the slope, we don't have to worry about any of the other ones affecting r. So I can say Newton's second law perpendicular to the slope. I can say that r equals mg cos alpha, which means friction then is 1/12 of mg cos alpha. I know cos alpha is 24/25, so that is 2 mg/25. And I'm going to use that in my expression in a sec, in my equation in a sec. Acceleration is down the slope, so let's take down the slope as positive. So I'm going to have mg sine alpha minus friction, which is this, minus the variable force, which is mv, and then that is equal to ma. Now I could write m times dv by dt, but I would rather write ma to begin with. Notice I have a common factor of m everywhere, so I'm going to get rid of that. Sine alpha is 7/25, so 7g/25 minus 2g/25 minus v equals, and now I'm going to make the swap. A is dv by dt. So what am I going to do? I'm going to write that as 5g/25. In fact, no, I'm not. I'm going to write it straight away as just g/5 minus v equals dv by dt, and then I get my answer. Okay, therefore g minus 5v equals 5 dv by dt. There's a lot of work involved in that. That's 5 marks, whereas they're normally 2 or 3. So that's a lovely question there. I'm going to move on. Given that the partial is initially at rest at the top of the slope, find an expression for v in terms of t and g. So given that we had a differential equation in A, we can probably go on autopilot here and separate the variables and solve. So I'll just recall the result from last time. Okay, so I'm going to get the dv on the what's currently the left and everything involving v on the right. Okay, and then integrate. So the integral of 1 with respect to t is going to be the integral of 5 over g minus 5v dv. Now you could choose to move the 5 as well if you wanted to. The reason I'm not is because I've noticed that when I deal with this term here, I'm going to get a 1/5, which is going to cancel that out. So when I integrate the left-hand side, I'm going to get t, and I'm going to put my constant of integration over here because I want an expression for v, so I want to isolate v, so I may as well put the constant of integration on the other side. So I'm going to get 5 times the natural log of the bottom divided by minus 5, which is going to give me negative of the natural log of g, I said g and I wrote 5, g minus 5v. Okay, I'm going to rewrite this now before I use the initial conditions. No, I'm not. I'm going to use the initial conditions. No, I'm not. I'm going to say that g minus 5 is equal to e to the power minus c minus t, which is going to be a e to the minus t, where a is e to the minus c. And so I can then say that 5v equals g minus a e to the minus t. So v is g minus a e to the minus t over 5. And if I remember rightly from before, I know that when t equals 0, v equals 0. So 0 equals, what am I going to get? G minus a over 5. So a is equal to g. I think, yeah, a equals g. Therefore, v equals, and I'm going to write this a bit more nicely now, g over 5, 1 minus e to the minus t. That's a lovely solution. Okay, to avoid damage, the speed of the parcel must be restricted to 2 meters per second. Determine whether or not the speed of the parcel exceeds that. So looking at the form of the solution that we've got in part B, we can see that this thing is slowing down. We're taking away, no, it's not, ignore that, it's speeding up because we're taking away something that's getting smaller and smaller and smaller. So this thing is at its fastest as t tends towards infinity, as t gets very, very large. So as t tends towards infinity, 1 minus e to the minus t, well, the e to the minus t term tends towards 0, so that tends towards 1. Therefore, v max, the limiting value of the velocity is going to be g over 5, which is approximately equal to, well, I know it's going to be less than 2, because 9.8 is less than 10. 1 is not approximately equal to, but it's 1.96 meters per second. So I can then say, no, it will not exceed, therefore will not exceed 2 meters per second. Okay. So yeah, that's important. Lovely. And that's the end of the paper. All right, thanks very much. Bye-bye.